Hey guys, packet 9. This one and one more to go. Now, we did questions on all 4 sheets, so we're really just picking a couple questions here and there to kind of support our learning. So let's dive in. If you look at my notes here, it looks like the only question I didn't answer was number 8. So let's kind of zoom in and make sure you put your name on your packet. And again, this was, you either did this lesson on 5:10 with Mr. Corson or today with me on 5:11. And this is period 1 or 6. Okay. Question number 8, which function is increasing over the interval? All right, so we can just purely look here. Does it go up? It looks like it's plus 3, plus 3, plus 3. So that's definitely increasing. If we plug in -5 for x, and okay, so -5 squared, -5 plus 1, we get so that's -25 plus 11, which would be negative 14. And now let's look for it at -1. So y equals -1 in my x. So I'm just substituting where I see the x. So we get -1 plus 2 plus 1. So we get 2. So if we look at the interval, change in y over change in x, we know that x changed from -1 to -5, right? And the y changed from 2 to 14. So that would be 2 plus 14, 16. And -1 plus 5, so that's 4. All right, so it looks like which function is increasing over the interval from -5 to -1. So although this looks like it's increasing, I can't see where it's increasing from -5 to -1. Does that make sense? But it's definitely increasing in function A, because I actually have it increased from -14 to 2, and that's definitely increasing. Here, I'm not sure. If it's linear, it definitely would be increasing. If it's something like this where it's decreasing and then increasing, we'd have problems. Does that make sense? Maybe it's a V where it's decreasing and it's increasing. So we know during the section that they've given us, it's increasing by 3, but we don't know this section. It could be decreasing or not. Okay, question number, looks like we did these two, depending on the class. So let's dive into one of these. It says, I'll look at question number 4. It says the graph of the amount of water left in a 13-gallon tub after 10 minutes. So if I look here, it looks like my intercepts, which is a big thing we focused on today, right? Our y-intercepts. It looks like at x, so when x is 9, so at 9 minutes, there's no water left, right? It looks like at between 12 and 16, so at 14, but then that would be at 0 minutes, right? At 0 minutes, so in the beginning, there's 14 gallons left. What is the average rate of change? Okay, so that's the change in y over the change in x. I can pick any 2 coordinates, and I have those coordinates. So here this coordinate is 0, 14. Here this coordinate is 9, 0. So how are the y values changing? 14 minus 0, right? How are the x changing? 0 minus 9. So they're going down by 14 and 9. And that is the average rate of change. All right, now let's look to question number 5. It says Mary is adding orange juice to a 10-liter capacity jar. This is the equation that relates to the amount of juice in liters with the number of minutes you add juice to the 10-liter capacity jar. How much juice was in the jar to start with? So that means at time 0. So when we put 0 here, we get 0 minus 2y equals 5. So if we do a little computation, we get 0 is equal to 5 plus 2y. So we must subtract 5 on both sides. And we get negative 5 halves, or negative 2.5. So it seems odd, but that's what I get here, that how much juice is to start. I get a negative amount of juice. Oh, I missed this negative. Okay, so let me add this. So if I add a negative here, that would be a negative, so that would be a positive. Okay, so that's be a positive 2.5. Okay, so positive 2.5 liters are there to start. At what rate is the jar filled? So when we think about this, it's not in slope intercept form. The rate is m, so we know the rate if we can get it in this form. So we kind of rearrange this. I think you can kind of see that here. So 3x minus 2y equals negative 5. That if we add 2y on both sides, we get 3x minus 5 plus 2 times y. And then if we add 5 on both sides, we get 2y equals 3x plus 5. So if we divide by 2 on each term, we get our slope. So it says, what is the rate? 3 halves, or 1.5. So it's 1.5 liters per minute, right? That's our rate. Nice. Okay. So let's look at a couple of questions here on a different learning goal. It says, Felicity wants to model the relationship between temperature and humidity. Select the words that complete the statement about the type of model Felicity wants to use. The relationship would be linear, right? Because the specific humidity increases by a difference over a certain interval. So what relationship must be true to justify this type of function? That would mean that the change in y, slope is, or the rate of change, would need to be equal to the change in y over the change in x. So the change in y it would be any y. So if we change these two here, it should be equal to, if it is in fact linear, then the rate of change doesn't change. So if it's going up by 3 degrees every time, then it's got to go up by 3 degrees every time. So linear means the rate of change doesn't change. When we look at exponential, we notice that the rate of change changes, right? So it's doubling. So maybe it's going up by 2, then it's going up by 4, then it's going up by 8. Notice the rate of change changes because it's doubling each time. So I personally like C. Okay, now let's look at our last page. There's a couple questions we could pick here. Which equations suggest exponential? So again, we mentioned this. It's when instead of it going up 3, up 3, up 3 by adding, that would be linear. We would look for something where it's going multiplied by 3 each time. Okay, so if we look here, it looks like that went down 8, down 6, down 4, down 2. Okay, that's not steady. What about this? Here, it went down and back up. Here, up 1, up 3, up 5, up 5. Interesting, right? Here, up 2, up 4, up 8. That's doubling each time, right? Up 16. Yeah, I'm liking this. This looks like it's doubling each time. All right. Determine whether the data is best modeled by a linear, quadratic, or exponential. So linear goes like this, quadratic goes like this, and exponential goes like this. Now we know each of these could be negative. So it could go down, it could be going down, or it could be going down like that, right? Okay, so what is the first difference? So what is happening here, right? So it looks like in the first difference, it's going up by 11, right? Or 21, excuse me. That's 15. That's 9. That's -3. Notice this is going up by 6. 6. So this looks like it's exponential, right? Because the second difference is 6. So it merely looks like they're multiplying, and that number is getting bigger. All right, I think that's it, guys. Thanks for joining us.